Hi children. Last class we have seen how do a metal and a non-metal react together. So this class we will see more about it, and we have seen that sodium and chlorine are reacting together to form sodium chloride. In the case of formation of sodium chloride, sodium is a metal and chlorine is a non-metal. So a metal and a non-metal reacts together to form a compound there, sodium chloride, and during that time sodium loses one electron and that electron is gained by chlorine, and sodium forms sodium ion and chlorine forms chloride ions. So Na plus and Cl minus ions will be produced there. So oppositely charged ions, they will have a strong force of attraction, and because of that strong force of attraction the compound is produced there, and those compounds in which compounds are produced by the attractive force of oppositely charged ions are known as ionic compounds, that we have seen in the last class, isn't it? Ionic compounds are also known as electrovalent compounds. They are also known as electrovalent compounds. Ionic compounds are also known as electrovalent compounds. Okay, we have seen last class how the sodium chloride is produced. Same way, today we can see few more examples of formation of different ionic compounds. For example, magnesium oxide formation. We can check it how this magnesium and oxygen reacts to produce magnesium oxide. We know that magnesium symbol is Mg and atomic number is 12. So electronic configuration is 282, that you know. Then during that reaction, magnesium will try to attain its stable octet configuration. So these two valence electrons will be lost and forms a 2 plus ion. So during the reaction, magnesium forms Mg2 plus by losing 2 electrons. At that time it will have that electronic configuration which is stable 2,8. Then oxygen, you know oxygen atomic number is 8. So electronic configuration for oxygen is 2, 6. For oxygen electronic configuration is 2, 6. So while reaction it will gain 2 more electron to complete its 8 electronic configuration, which is a stable one. So at that time, after gaining 2 more electron, oxygen will convert into O2 minus. O2 minus. So at that time 2 more electrons will be added to normal oxygen, so it will complete its 8 electronic configuration. While the formation of magnesium oxide, we can see the electron dot structure, how the electrons are produced there. Mg, outer electronic configuration only we are showing there, the 2 electrons there, and reacts with the oxygen with 6 electron. Okay, so 6 electrons are already there in oxygen outermost shell, and these electrons will be moving to there and it will complete its octet configuration. Mg will be converted into Mg2 plus, oxygen will be converted into O2 minus. So this will be the compound magnesium oxide. Either you can write like this or you can write Mg2 plus O2 minus. This is the electron dot structure for the formation of magnesium oxide. Now we can moving on to next compound. We can see other example, formation of magnesium chloride. You know what is the formula for magnesium chloride? It is MgCl2. We can see how this is formed by combining magnesium and chlorine, how this magnesium chloride is produced. Same way, now we can see the electron dot structure only. So magnesium, we know that outermost shell contain 2 electrons and chlorine, there are 2 chlorine atoms. So one chlorine atom, it has the outermost shell 7 electrons. To complete that octet configuration, it will gain one more electron from magnesium. So 2 chlorine atoms are there which will gain one each electron from magnesium, so that it can complete, they can complete their octet configuration. So we can see how this chlorine outer electronic configuration is 7 there, and this electron will be moving to here, and one more chlorine is there at that time. Here also 7 electron, and this time it will be transferring to this chlorine, another chlorine, so that magnesium chloride will be produced there, Mg2 plus again. Mg2 plus again, so like this, and Cl minus. So here we can show the 8 electrons there for one single chloride ion, and like this MgCl2, magnesium chloride will be produced there. This is the electron dot structure for the formation of magnesium chloride. Same way, we can show the electron dot structure for the formation of calcium oxide also. Calcium oxide, what is the formula? CaO. Okay, and there also calcium oxide, calcium contain valence 2 electrons. The valence electrons are 2 there. So that 2 electrons we can show here, and it will be reacting with the oxygen. And you know, one single oxygen requires 2 more electrons to complete its octet. So both the electrons will be transferred to the same oxygen. So at that time, calcium oxide Ca2 plus O2 minus will be produced there, and we can show the electrons there. Okay. And if you want to show the different electrons from this 2 cases, one we can show it as a different expression, that is a positive sign or plus sign. We can take it for noting that electrons present here in the case of oxygen, that we can, I will show you this, that is also possible there. This I can put it as plus. So this electron will be transferred here, easily we can identify that. So this electron will be transferred here, and again second electron to oxygen. So that can be denoted by showing the positive sign, so that we can easily understand which electron is coming from calcium. Okay. Then we can show the formation of different ionic compound like this by the transfer of electrons. So we can say that ionic compounds are formed by the transfer of electrons from a metal to a non-metal, and this ionic compounds are also known as electrovalent compounds. So these are the electron dot structure for the formation of different compounds. Is it clear, children? There will be question, you have to draw different electron dot structure for the different formation of different compounds. There will be a 1 mark question, or it can be a part of 3 mark or 5 mark question. Now on moving to properties of ionic compounds, we can see properties of ionic compounds. Ionic compounds are also known as electrovalent compounds. So in this case, what are the properties of ionic compounds? We can see that. First property, we know that most of the ionic compounds are crystalline solid in nature. They have very high force of attraction between the oppositely charged ions that we have seen. Positive and negative ions are produced there, and they will have high force of attraction between. So they are all existing in solid state. As the force of attraction is very high, they will be in solid state. And as they are crystalline solid, we can break by applying pressure. They are brittle. We can break these solids into pieces by applying pressure. So we can say that ionic compounds are crystalline solids. On the application of pressure, we can break them into pieces. So we can say that they are brittle. Okay. Now the second property of ionic compounds, we can see that they have high melting point. Ionic compounds have high melting point. Why do they have high melting point? Because we know that they are existing in solid state. And in that solid state, they have very high force of attraction between the oppositely charged ions. Interionic force of attraction between them is very high. Because of that high force of attraction, if we want to convert them into liquid or any other states, we have to apply that much heat energy. So very high heat energy should be provided for them to convert them liquid state. So their melting points are very high. In all these cases, you will get some reasoning, give reason questions or why, that type of questions also will be there. Why ionic compounds are crystalline solids? Why? What is the reason for the ionic compounds are high melting point? What is the reason? Like this, give reason for that. Like this, different questions you will get from this topic. So it is very important. Now we can see third property. As they are solid in nature, they can dissolve. Most of the ionic compounds are soluble in water. As they are solids, so most of the ionic compounds are soluble in water. Soluble in water. And they are insoluble in organic compounds or such as petrol, kerosene, etc. As they are soluble in water, they are insoluble in organic solvents. Okay. Insoluble in solvents such as like petrol, kerosene, etc. Now we can see, moving on to the next property, we can see next properties is conductivity of electricity. conductivity of electricity. See how a particular material will become conducting, because there will be movement of charged particles. If there is a movement of charged particle in that material, definitely they will allow the passage of electricity, or we can say they are good conductors of electricity. In this case, this ionic compounds or electrovalent compounds, they have charged particles such as positively charged ions and negatively charged ions. That is there. So, in the case of solid state, they have a rigid structure. In solid state, they have a rigid structure, so the ions are not allowed to move there. These positive and negatively charged ions are not allowed to move there. So, the movement is not there in the case of solids. So, they are poor conductors of electricity, or they will not conduct electricity in solid state. We can see. Solid state, they will not conduct electricity. What is the reason? As they have a rigid structure, there is no movement of ions. There is no movement of ions, so they will not conduct electricity. Then second case, that is if they are made to liquid state, that is if you are heating them, they can overcome the forces of attraction between the ions, and they can convert the solid state to liquid state. Solid will be changing into liquid state. So, we can say that in molten state, they will conduct electricity as the movement of ions are possible there. So, in molten state, it conducts electricity. So, in the case of ionic compounds, in solid state they do not conduct electricity, but in molten state they will conduct electricity. Okay. Then in dissolved in the form of water, some salts, I told that they are soluble in water. So, they are solutions. When they are dissolved in water, or they are made to dissolve in water, their solution will be completely conducting electricity, because in that solution also movement of ions are there. So, in solution state, they conduct electricity. So, there are three conditions for the ionic compounds when we consider the conductivity of electricity. First one is in the case of solid state, they do not conduct electricity as they have rigid structure, movement of ions are not possible there. But in the case of molten and solution state, dissolved in water, both the cases there will be movement of ions, both the cases they will conduct electricity. So, these are the four different properties of ionic compounds or electrovalent compounds. All these from the properties of different ionic compounds, there will be give reason type questions. So, why do this ionic compounds not conduct electricity in solid state? Or you will get why do they conduct electricity in molten or solution state? What is the reason? Then why do they have high melting point? Why do they are appearing as crystalline solid state? Like so, different questions will be there from this point, this topic. So, it is very important. So, children, I think that formation of ionic compounds are very clear. In the case of concluding the topic, in the case of formation of ionic compounds, we can see a metal and a non-metal are reacting there to produce an ionic compound or electrovalent compound. During that time, transfer of electron will be there from a metal to non-metal for completing their octet configuration, which is very stable. At that time, oppositely charged ions will be produced and they will have high force of attraction, and that is the reason for the formation of ionic compounds, and the bond existing between the ionic compounds are known as ionic bond. And when we talk about that electron dot structure of formation of different compounds, electrons will be transferred to anions, non-metal there, and anions will be produced there, and we can draw the electron dot structure for formation of different compounds like this. And after that we can see that properties of ionic compounds. Ionic compounds are crystalline solids, and if we are applying pressure we can break them easily. And they have high melting point. As the force of attraction is very high, they have high melting point. And most of the ionic compounds are soluble in water. Water soluble compounds are there, and they are insoluble in solvents such as petrol and kerosene. Then the fourth property, ionic compounds conduct electricity at certain conditions. In solid state they do not conduct electricity, and in molten and solution state they conduct electricity because there is movement of ions. Due to the movement of ions they conduct electricity. Movement of ions are here, and in this case there is no ionic movement. Okay, so that's all about the ionic compounds. Thank you.